Right, so this is about making PHP do something it really wasn't ever designed to do, which is something I do quite a lot. But hello, I'm Michael Maclean. You might know me as MGDM online or at MGDM on Twitter. I have a blog on mgdm.net and you can email me there. You can see a theme developing. So, I've talked to a few people about, I've done this talk before, and I've talked to a few people in the conference before now, and when I said what I was talking about, the reaction I got pretty much every time was this. Why on earth do you want to do that? And essentially it comes down to, because I can. And also, it's quite cool. And I like doing things that I know nobody has ever done before and probably never will ever again. But another part of it is that PHP is very good, well, comparatively good anyway, at making graphics. So there's lots of ways to make graphics in PHP. Hands up if you've ever used GD, for example. Yeah. Cairo? Anyone ever heard of Cairo? No, that's another one I work on, so check it out too. You've also got, for doing things with images, like photos and stuff, you've got Image Magic and you've got Graphics Magic, which are also quite good, slightly differently targeted. But until now, you've not really had any way to find anything out about the contents of an image, unless you went and wrote it yourself. So I decided to, there's a library called OpenCV, which stands for Open Computer Vision, and it's a library of lots and lots of functions for doing things to do with processing images. It was originally built by Intel, I think as a tech demo for some of their fancy compilers, but they BSD licensed it, and a company called Willow Garage, who are famed for making robots of various forms, seem to now look after it. There's a variety of things you can do with it. So one of the things is object recognition. So you can use it to feed camera detail into it and figure out if things you're looking for are there. An extension of that is face detection, which is something a lot of people seem to think is quite cool. You can also do other things with it, like gesture tracking, so you can figure out what someone's doing with their hands, and an extension of that is figuring out what orientation things are and other such things useful for robotics. One of the other things you can maybe do with it is called structure from motion, which is where you get two cameras or maybe one camera and then you spin an object round and you use that information to create a 3D model. Now, I'm not saying you should do this in PHP, but it is within the capabilities of the CV library. Quick disclaimer. I'm not actually an expert in computer vision in any way. I am playing with this stuff because it's quite interesting and I'm learning as I go. So if I get any of the stuff wrong, if there's any math geeks in the audience, then please let me know afterwards or whatever if I'm getting it wrong. So the extension itself is on GitHub, on my GitHub, which you can probably predict the URL. In order to install it, you need PHP 5.3, and I'm working on making it 5.4 compatible, which just needs a couple of extra lines that I need to add later on. You also need the underlying OpenCV library, which is in pretty much every Linux distro these days. It's certainly in Ubuntu and Debian, and no doubt in Fedora and CentOS. If you're on Mac OS 10, you can install it using Homebrew, very simply. And on any of those, Linux or Mac OS, it's just your usual way to install a pickle extension from source. So you do phpis, configure, make and make install. This is all documented in the README, and you've probably done it all before. Hands up if you haven't. That's good. If you're on Windows, then I'm sorry. I don't use Windows, so I haven't made it work yet. But if any of you do and are suitably inspired, patches are welcome. So, I'll go and do a wee bit of a demo first. Loading an image, which is pretty much the most basic thing you're going to want to do. What you do is use the object that you're going to load it into is called an OpenCV image, and it's got a method called load, and you give it the path to a file. And then on the second line there, I'm saving it back out. That's all there is to it. That's not very exciting. But once you have an image, it lets you do various things with it. So OpenCV treats everything, every image that you load is essentially a very big matrix of numbers. And so there's a whole bunch of the sort of maths type matrix operations you can do on them. Things like adding, subtracting, transposing, inverting. And you use the same object type actually for any matrices that you use for other things, some of the more complicated operators that I'll come to later. It's also got, obviously, a bunch of image-specific things you can do. For example, this one is to do a blur on an image, which is not very exciting, but it's relatively simple to do. So here's my source image, and I blur it, and it was blurry. Hey, that wasn't very exciting, but you know, that's the first step. So that's useful. Making things blurry is maybe you don't think is all that useful, but it is. If, for example, you've got a camera that is working very low light, you can use a very subtle blur in it to remove a lot of the noise that you get, which makes the objects easier to see, the things that you're looking for later. So there's a bunch of different ways you can blur things. As you can see, all of these are available in Photoshop and GIMP and all that kind of thing. There's other things that are getting a little bit more technical. You've got a set of operators for image morphology, which sounds really cool, but it's not especially exciting because there's going to be a bit of maths in it. So these are functions where you take an image and convolve it with a kernel, which I will now explain. A kernel is essentially a matrix like this. So this is a 3x3 one. And what you do is you take that kernel and you overlay it in turn on every single pixel in the source image. And then the numbers in these determine how much of that source pixel appears in the destination. Does that make sense? Right. So here's an example of what you can do with that. It is known as dilation. So you take your 3x3 kernel and you scan it across the image. And then the highest value that is covered by that kernel becomes the new value of the pixel in the destination image. Okay? Does that make sense? So the upshot of that is that bright areas get bigger. And then you've got the opposite operation, which is called erosion, which is the same, but instead of taking the highest value, you take the smallest value the kernel covers, and then bright areas get smaller. So these things are useful for if you're taking a photo of, say, a car, but it's behind a tree, there'll be a bunch of the branches will have overlaid on it, and if you use the open operation on it, then those branches will just disappear because the car behind it will get bigger. And it doesn't generally affect the shape of an object too much. So here's my original test image again. And if I run dilation on it, the bright areas get bigger. As you can see, all the little small bright areas are now quite big, blocky, pixelated ones. And if I run an erosion on it, the bright areas get smaller. So a lot of the smaller bright details have disappeared completely and have been just replaced with the surrounding dark, except for things like the fence and the sky. So, yeah, in and of these in themselves, these are not very exciting. But once you've done that, and to get rid of some of the noise, you can move on to doing things like edge detection, which is you get the outlines of objects. So there's a few different ways you can do that as well. You've got a thing called a Sobel operator, which is where you get the derivative of an image. So you essentially get a lot of you get bright bits where there's a lot of contrast in the image. So lots of small details with large differences in color will come out quite bright. So here's the original image again. If you run one of these on it, you end up with something like that, which doesn't come out very well on this projector, but the outline of the fence and of the train and everything, they're all quite bright white compared to the rest of it, which is dark. And there's another one called the canny operator, which gives you a slightly different thing because it works in both directions, X and Y. And so you get much clearer lines, but it's good to do a bit of filtering before you do it because as you can see, every single line in the image has just come out now and you need to sort through that mess to figure out what it is that you're looking for. So yeah, that's Not dramatically exciting maybe either, but moving on to slightly cooler stuff, you can do a thing called template matching, which is where you can use OpenCV to find one image inside of another one. And so here's my sample image, which is the side of an elephant. Everyone is aware of the elephant, I'm sure. Yeah. So here's a sample, and we're going to look for that sample image within the target image, which I got from Michelangelo in Belgium, I think, or is he in the Netherlands? I can't remember. And yeah, he got quite a lot of elephants for some reason. And so I load in the first image and scan it over the second one, and this is all the places where it matched. The white areas are the matches. And so you can see that anywhere that's roughly the right color, it matches. The only problem with this is, though, that I took my sample image and then saved it as a JPEG. And so the pixels in the underlying image are not quite identical, which didn't really help matters. But we can fix it. We have technology. There's another way you can do these things in OpenCV, which is to use histograms, which everybody probably thinks of as bar charts and things like that, which is actually fairly accurate in this case. So what you do is you take a bunch of values, so like the color values in each pixel in your image, and you can put them into slots based on, well, these ones are between, say, 0 and 10, 10 and 20, 20 and 30, and so on. But, so it's stored in roughly an array, and you could draw it as a bar chart if you want. But what we can do in OpenCV is use histograms as a sort of hash of features that you're looking for in an image. So you can use a histogram to record the colors of a section of an image, such as my little sample one there. So what I'm going to do is convert my sample image to a different format called HSV, which stands for hue, saturation, and value. And so essentially the color is a number from 0 to 255, and how much of that color is the saturation value, which is also 0 to 255. And then we can do a thing called back projection, which is where we get OpenCV to look for things that match that histogram in a target image. So here's some code. At the top there, we just load in or use the objects that we need. My source image is the sample one, which is I load in, convert it to HSV on that line there, and then split it into 3 different images, one for each H, S, and V. And then I take the just the hue value and make a histogram out of that, which is that line that says histcalc. Can you see that? Then I load up my target image and convert it to the same format. And then using the color plane again, I back project that and save it as an output. So this time I get this, which is a bit clearer. You can far more easily see which are elephants and which are not. And then you can go on and do things to count how many there are there, the counter with contours and things, which is something I've not implemented properly yet. But as you can see, it's a much better match. So histograms you can use for quite a lot of different things. You've got, you don't have to just use colors. You can run an edge detection algorithm of some sort, and then run that through a histogram, which gives you a sort of hash of the shape of an object, which you can then use to go and find in bits of the image. So one of the applications I saw for this was for gesture recognition, where someone took a bunch of photos of his hand up to a webcam going like that, and then like that. And he uses it to control an MP3 player on his computer. So it goes like that, and it will stop or start, and like that to skip the track, and that to go back to the previous track, which is quite cool. So I wouldn't, again, recommend that you did that in PHP, but hey, why not? You've got PHP GTK, you can do that. Got other features in OpenCV are the machine learning. So there's a lot of machine learning code in OpenCV because it's also used in a lot of robotics applications. So there is a bunch of stuff like support vector machines, which, did anyone see Andre's talk yesterday about the small data machine learning stuff? He was talking about those. There's Ian from Google has also written a PHP extension that just does that. You've also got your Bayes classifiers and a bunch of other algorithms, so you could write an equivalent of something like Spam Assassin in there quite easily. They're all fairly generalized. So, like I say, you could use them for things that are not image recognition, not specific in any way. But I'm going to talk about a couple of them here, which are algorithms that you need to train. So, there are two different kinds of algorithms in machine learning, stuff in OpenCV. There's ones where you do supervised learning, which is what Andre was talking about. So you have a bunch of data that you feed into it, and you've extracted features from it, and give them labels. And oops. So you give them labels, and you tell it, these images have these features, and these ones do not have these features, and then it learns to differentiate between the two. You've also got the unsupervised learning algorithms, where you don't tell it in advance whether there are features there that it's looking for or not. And it just figures out what images are similar and clusters them together. So they're called clustering algorithms. But I'm going to move on to one of the the supervised algorithms there, which is called a HAR classifier. Now, this is a pretty specific algorithm that is used in OpenCV to find mostly rigid objects, which include things that don't change their shape very often. So you could train it to look for, I saw one guy who went through satellite imagery looking for tennis courts, and he has an I think he's added it to OpenStreetMap now. He's added every tennis court in the continental US to OpenStreetMap this way. I don't really know why, but that's cool, so why not? But another thing you can do it for is face detection, as I was talking about earlier. So the guys at OpenCV seem to have realized that a lot of people are going to want to use this stuff to interact with software that they want to find. Let me just start that again. A lot of people are going to want to do face detection. So they have already trained it for us with a bunch of data. They've got access to an image library of many thousands of images. And so they've already trained it for us. So we don't need to go and do that ourselves. And the training data is supplied with it in an XML file. So if we want to go looking for faces in a particular image, we load an image, and then there's a method called HAR detect objects on that image object, and then you pass it the path to the XML file that comes with OpenCV. So that'll probably be in user share or something like that on a Linux system. And then it'll give you a bunch of rectangles as results, just point values. And then you can use that to draw a picture, or draw around the detected spots on the image. So here's my test image, and we run the HAR detect algorithm on it, and this is the output. Now, you'll notice a couple of things. Yes, it has picked up James there, which is fine, but also it's picked up an image down here and one over here. So it's not foolproof, but it's better than nothing. There were ways you can ways to cut down on the false matches by doing things like there's a confidence value that comes back, or you can look for ones that are only above a specific size. So now I think I've typed that. I've run out of slides, however. I do have a couple of things I would like to demo, so if you give me a moment, I'm going to go and set them up. Does that open up there? No, it doesn't. Right, so one of the things you can do, which is reasonably interesting, is to, you can actually, from PHP, use the camera inside a laptop or whatever. And so, does anyone know how to put the font size up in gedit? I can't remember. No, okay, never mind. So we create a capture object at the top there, and then just run query frame on it, which is the method that you run on the capture to go and grab an image. And then we take that result image and run the detect objects function on it again, just like we did in the previous slide. And then we save out that image there. So I'm going to give that a go now. And it may go horribly wrong. So it actually worked. And so my camera takes a little while to fire up, so it hasn't really adjusted to the lighting in here. But you can see it still figured out that I am there, which is quite cool. But it's also detected something up here on the projector. I don't really know what that is. But so yeah, it's not foolproof, but it works. There are a bunch of things, other things in OpenCV that I should probably mention as well. In the most recent release, there's a set of functions for running panorama stitching, so you can upload a bunch of images that were taken side by side and get it stitched together into one big long one. I was hoping to demo that, but sadly I didn't get it working in time, so I decided to strip it out. But having run out of time, I should probably put it back in. Right, are there any questions?
You've got the microphone there.
Yep, sorry. I think you were first.
For the face detection or facial recognition versus face detection, is there any way that I could say have a library of photos and then using OpenCV as someone standing in front of the camera, I can then match some
Sorry, it's easier to see.
Start again. So if I had a library of photos and then obviously someone standing in front of a camera, is there any way through any of sort of methods that OpenCV uses for facial detection that can actually sort of put some kind of code against each photo and then go, that's Fred, that's John, that's Bill?
You could do it. I think it would probably need quite a lot of training for each person. I'm not sure. One way I suppose you could do it would be the face detection stuff gives you a bunch of parameters, like where eyes and nose and everything are, so where the various features are. So you might be able to do something like put that into a histogram, so that then you use that as a hash to look for that in other images, but it would be quite slow.
That's the point. In your experience then with that histogram, would it only work then if the camera was sort of reflected exactly the same sort of light conditions and everything as the original photo?
Well, the face detection stuff isn't looking for like lighting, really. It's looking for features in roughly the right proportion. So it's reasonably good at handling different lighting conditions. But obviously, if you had like very extreme shadows, like if the light was really bright and right here, then you might run into trouble. But it should work. The thing that is that most of the training data that comes with OpenCV is designed to look straight at faces straight up. So if you had someone like side on, it wouldn't detect them. But I'm sure it's doable. I haven't tried yet.
Hi, you've suggested a couple of times, I think, that maybe PHP isn't the best language to do this in, or it's kind of a crazy thing to do. But I'm wondering, doesn't the OpenCV library do most of the heavy lifting, or do you find that actually you have to do a lot of calculation in PHP as well?
No, yeah, you're right. The heavy lifting is pretty much all done by OpenCV. All I've done is write a very reasonably thin layer over the top of it to make it accessible. So, yeah, I mean, in terms of speed, you're not all that much slower, really, than doing it from a C application or whatever. It's just that in terms of things like memory management and stuff, you probably don't want to be doing it when you're loading PHP pages. You could probably do it from a back-end task or something like that. And that's part of the reason why I wrote it, was to make it accessible to, you could run it from a Gearman or a Beanstalk-D task or something like that in the background, without having to write something in a completely separate language.
Sure, that's cool, thanks.
I think there's one in the back.
Hi there. One of the things that I've been looking at recently is when people upload profile images, which can be the pictures of their faces or sometimes logos, what I want to do is square off them and centre on either the face or the object. Do you know if the HAR classifier has any other data sets that might be useful there?
Well, it will return a sort of rectangle for where their face is, like the bounding box.
Yeah, so that's fine for faces, but is there anything for like spotting the most prominent object in an image, or?
You probably wouldn't do it with a HAR classifier unless you were able to train it to look for that very specific object.
Right.
There would be other ways to do it, to look for the most dominant colour in an image and then find the largest proportion of that, or something along those lines, maybe.
Sure.
Anyone else?
Just wondering if it would be fast enough to do real-time processing, like a stream of images coming from JavaScript canvas sent to the server.
Yeah, I think it would, because it is originally designed to handle real-time vision for robot platforms and things like that. So if you can get the data into it fast enough, it'll probably work. One of the things about, say for example, you're using it to look for a face in real time, you'd probably use the HAR classifier once to find the bounding box of that, and then what you would do instead is keep on tracking that patch of the image using a thing called optical flow. There's a set of functions in there for handling. You give it 2 images, the before and the after, and it works out where the pixels have moved. So you'd probably use that because it's a bit faster to do than the HAR classifier would be. But yeah, it should work.
Thank you, Michael.